Hello everyone, we're here today for Chapter 5, Lesson 2. The title is Anti-Differentiation with U Substitution. So we're going to take the basic anti-differentiation we did in the last video, and we're going to up it a notch to something that looks a little bit more complicated, a little bit more than just a power rule in reverse. So if you take a look at this problem, it looks pretty crazy. You've got the antiderivative of x to the 4th plus 3x raised to the 30th power times the quantity 4x to the 3rd plus 3 with respect to x. So already this is looking nothing like anything that we did yesterday. What I usually have students notice, though, when they look at this for a little bit, is that they see that the quantity back here happens to be the derivative of this. If you take the derivative here, you get 4x to the 3rd plus 3. So I'm thinking that a chain rule must have been involved in taking the derivative of this original function we're searching for. Now, some students can just see the answer, like right off the bat. They can do it in their head, and they need not show any work. And to those students, I say, more power to you. I was never one of those students. So I'm going to show you the recipe. It's called U substitution. And this is the way you anti-differentiate when you suspect some sort of rule, like the chain rule, was involved in taking your derivative. Okay, so this is what it looks like. You put your problem on hold for a second, and you come underneath, and you identify your U. Okay? I always let my U be the stuff that's in the quantity being raised to the higher power. See, this is being raised to the 1st, this is being raised to the 30th. The only exception to this rule is when we get into square roots, because square roots you're raising to the half power, so I'll show you what that's going to look like a little bit later. But in general, I let my U be the quantity that's raised to the higher power. I also let it be, when I look at this, since this is the derivative of this, I want the U to be the thing, the main guy, not the little link on the back. That's another way, and that's what gets me through the square roots. So let's let U be x to the 4th plus 3x. Okay? Next, you find the derivative of U with respect to x. Basically, you're finding U prime, but I'm going to call it derivative of U with respect to x. So the derivative of this guy is 4x to the 3rd plus 3. Next, I'm going to solve for dx. So I'm going to algebraically solve this for dx. The way I'm going to do that is I'm going to multiply both sides by dx, which is going to cross these guys out and give me du equals 4x to the 3rd plus 3 dx. And to get dx alone, I'm simply going to divide both sides by 4x to the 3rd plus 3. So dx ends up being du divided by 4x to the 3rd plus 3. Okay, at this point, there's only two things we need. We need the first step, and we need the last step. All this stuff in between, it was good work to get this, but I really don't need it anymore. I'm going to take these two pieces of information off to the right side now, and I'm going to recopy my problem, plugging some of this stuff in. So I'm going to recopy my elongated S symbol. Instead of writing x to the 4th plus 3x to the 30th, since all that is called U, I'm just going to call all that U to the 30th. Now this guy back here, 4x to the 3rd plus 3, I'm just going to recopy him. And finally, in the back, the dx, if we look down here, dx is equal to this, so I'm going to substitute this in for dx. So du over 4x to the 3rd plus 3. Now, if I look at this problem, I can see that these two are the same, but one's on top and one's on bottom. So I'm going to go ahead and cancel these out, which is really going to simplify my problem to the antiderivative of u to the 30th with respect to u. Now, if you look at this, this is very simple. It's got only U's in it, no X's, which is what I want, and this looks like the power rule backwards from yesterday. Remember this guy from yesterday? The antiderivative of ax to the nth power with respect to x is equal to a over n plus 1, x to the n plus 1 plus c. Well, this is the same idea, only now it's the antiderivative of a u to the nth du. So that's going to be the same thing, a over n plus 1, u to the n plus 1 plus c. So my a is like a 1 right here. So when I take the antiderivative, I'm going to add 1 to the u to make it 31. I'm going to take the 1 that's out in front and divide it by the new exponent, 31, and then add c. Okay, so final step, we're going to put everything back in terms of x. This is going to give me 1 over 31 times, let's go back to what u was. U was x to the 4th plus 3x to the 31st plus c. This is my final answer. Now to check it, let's run the chain rule and take the derivative of this. Okay, so the derivative of my answer should give me back what I started with. Let's see if it does. 31 times 1 over 31 is 1. You rewrite the inside, you subtract 1 from 31, which gives me 30, and you multiply by the link the derivative of the inside, which is 4x to the 3rd plus 3. And this is exactly what I started with. So that's how I know I did it correctly. Okay, tune into the next video for some more examples on U substitution.